I guess you basically 50-50.
I don't know where I'm looking.
Oh, I'm
Um,
asking what letter would the -5 correspond with?
oh, C.
Yeah, the C. The C value is -5. We don't have to change the sign or anything. So then what the heck is K? Anna, what do you think? It's okay. That's okay. That's okay. The fact of the matter is, there doesn't seem to be any number multiplying inside the function, inside the x value area. Okay. In fact, it's not a 0, but it's a 1. Because if you have a 1 there, you multiply it and it doesn't change anything. So in this particular case, having no number there simply means that the k value is 1. Okay. Let me erase that and we'll get to 1. All right. So for being late, my computer decided now was a good time to be slow. That's okay. Felix, just remind me in case I forget. I just got to put you as attending instead of absent. Okay. Let's continue on. All right, let's move on to the square root function. Who's next? Claire, what do you think? What is the -2?
Pardon?
Which letter, A, K, D, or C, which letter does the -2 correspond with, you think?
Is it A?
It is A. Very good. Okay, so in other words, if there is a number multiplying the entire function in its entirety, that is basically like that. It's the A value. Good. So moving on, how about that 2 inside the function, inside the square root? Where are we? Dahlia, what do you think?
I'm not sure, but is it +2?
It is a +2, and it represents the K value. Okay, so again, if there is a number multiplying with the X variable, okay, that is indicative of the K value. Wow, I keep on deleting the text portion. I just have to give up on it. Okay, which brings us to a number that seems to add to the X value and a number that is adding way on the outside of the entire function. I'm going to finish this off. D is a -1 and C is a +1. Moving to the reciprocal function. Sometimes this could be a little bit tricky. Daniel, I'm coming to you. I'm not going to ask you for a specific number. Can you choose any of them? Just tell me what you do know, and then we'll move on to what we may not know.
The +4 is C.
For sure, right? Just like all the others, when the number is sort of adding or subtracting outside of the function, we know that it's representing the C value. What else are you like 50% sure but not 100% on? Is there anything else that you might put money down on?
Maybe the K would be 2. Oh, sorry, I'm looking at the wrong one. Maybe 3.
K could be a 3. Well, there is a multiplication involved in that, but unfortunately, it's not a K value. But that's okay. Let's correct it. The K value will always be I guess, a quantity, a number that is directly multiplying with the X variable. So in this particular case, is there something multiplying with the binomial that has the X variable in it?
Yeah, -1.
The -1. K in this case is a -1. Very good. Bringing us to the last two. Aaron, do you have an idea of what the other two variables might be, or another two values might be? Sorry, I said Aaron, but yeah. Aaron, are you here with us? No, it's not good. Going once, going twice. Felix, how about you? Do you know any others? No, Felix is not here. Great. Hazel, what about you?
Would D be or +2?
Good. It looks like a -2. The D value is a +2. Yeah, just be like, I'm not sure. That's fine. And the last one, the 3 is actually a multiplication, and I'll tell you why. If I have 1/x multiplied by 3, right? That's, if you remember, it's just multiplying fractions. And if you remember from our rational expressions unit, you just multiply across. So a numerator of 3, when it used to be a 1, simply means I've multiplied the entire function by the number. So when you see that, you know that we've multiplied the function by 3. Okay, so moving on, again, lacking time here. So I'm going to clear this. I'm going to propose a story that, or something that you may have seen before. Do you remember in elementary school, the teacher might have given you like, here's a point, and here's a point. It creates a triangle. All right, everyone. Use the corners of the triangle to slide this shape 3 units to the right. Do you remember that? So you take this corner, you do 1, 2, 3, it's now here. Take this one, 1, 2, 3, it's now here. You take this one, 1, 2, 3, it's now here. And when you connect the dots, you're like, whoa, it's the exact same shape. The shape is congruent, and it's slid 3 places to the right. Yeah? Do you remember that? I'm hoping you're nodding, but I mean, I can't see your faces, so it is what it is. There's some other examples. Like, for example, you could say, okay, let's use the x-axis and pretend that's a mirror. Can you mirror the black triangle using the x-axis? And you say, oh, okay, well, this is a 2. So if you mirror it, that becomes a -2. Here is a 5. So if you mirror it, it becomes -5. And here is a 3. And if you mirror it, becomes -3. Bam, bam, bam. Hey, we're able to flip it or reflect it on the x-axis. And the final exercise is, oh, can you do all of them at the same time? Well, after you flip it, you move it 3 to the right. You move this 3 to the right. You move this 3 to the right. And all of a sudden we have, you know, a double transformation on this triangle, right? So instead of this triangle, for this entire unit of chapter 2, I'm going to give you a random function, right? I can give you like, ooh, I can give you something like that. I can give you a trapezoid. I can give you anything I want to, but if I ask you to take the accuracy points, right, like the corners of the curve, and I ask you to slide it based on some number, I hope that you'll be able to do that with relative ease, okay? And that's where the AKDC comes in, because whatever these numbers are tells you specifically how to move or transform the parent function, okay? Any questions before we begin? Going once, going twice. All right, everyone, we're gonna blitz through this as fast as we can because I really wanna get through this entire package and leave you with some exercises that you could try on your own and something that you can chew on before I see you 2 o'clock tomorrow, all right? So I told you before that I'm going to give you some random function to work with. I am not going to give you the square root function. I'm not gonna give you the reciprocal. I'm not gonna even give you a parabola. Here is your function. This is f of x. It's a random shape that I made. It sort of looks like a bucket or a gourd if you're, or the Big Dipper if you're into constellations. Okay, every single transformation that I do from now on is going to use this as my f of x, this as my parent function. Let us begin. Please go down to the first one. There will be times when you are going to transform and the entire function is going to be added or subtracted by a number that is completely outside of the original function. Quick recollection. Who remembers this? I hope. James, do you remember what this represents and what that represents and what this represents? Give me one of them.
The A would be the stretch or compression.
Yeah, vertical stretch or compression. Very good. Jordan, do you remember what H or K was for a parabola?
Isn't K like the maximum or minimum? Or they're like the 2 points?
Yeah. Yeah, so these are the 2 points that created the vertex. Very good. But when we talk about the square root function, when we talk about the reciprocal, if you look at the graphs that we graphed yesterday or in class the other day, yeah, did they have vertices? No. So that's why we can't use H and K anymore, but it still does transform according to the same system. The H is basically a horizontal shift. It goes left and right because, you know, the vertex that used to be 0, 0, if there's an H value, it shifted it left or right, okay? And the K value is a vertical shift. So between these three, I think you can make some parallel. When there is a number that is adding or subtracting to the function outside of the function, we are going to move the entire function up or down. So if this is f of x, I'll do the first one in red. This accuracy point for f of x plus 4, the y value is going to be increased by 4. 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. Bottom point, 1, 2, 3, 4. And the pattern continues. This is going to be my f of x plus 4. Okay. This number, anything that you're going to be adding outside, this is what we would call the C value. It is a vertical shift, up or down. The very back page of the handout that we're working on is going to have a big summary, so you don't have to worry about, I'm going to clarify everything as best as I can at the very end, so don't worry. Okay, if the positive value brings it up, then the negative value, I think you can guess, is going to be bringing it down. The y value is now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then here, and then here, and then here, and then here. Any questions for so far? Okay, while you might be working on that or trying to draw your own, okay, and filling in this chart, I want to give you a couple of examples. If f of x happened to be x squared, these two transform functions would look something like x squared plus 4. Again, the plus 4 is outside of the entire function. Or it could look like x squared minus 5, where the minus 5 is again outside of the function. If f of x was square root of x, that doesn't change. If we are shifting it up or down, the function itself would look like this, or it would look like that. The plus 4 and the minus 5 is outside of the original parent function. And lastly, if it is 1 over x, it would be 1 over x plus the 4. And of course, I'm running out of space. Oh, shoot. I can't do that, can I? Oh boy. Or it would be 1 over x minus the 5. Right? So this is what a vertical shift would look like. And I'm hoping that you see a similarity between all of these, because it's the same system again and again and again. Okay. What's next? Any questions? All right. If you're not sure, you can save your questions too. I'll take them at the end. I'm going to move on to page 2, so the back page, and look at what happens when you have a plus or minus inside the actual function. What happens when you have a number that changes the x value inside the function? Okay, so here it is. If you have something affecting inside the function, these are the horizontal shifts. Okay, so please note, once again, I'll do the first one in red. If it looks like a -4, it actually is because the value of this number, the d value, is +4. We are moving 4 to the right. 1, 2, 3, 4. And then 2, 1. And then 1, 4. And then 4, 1. And then 3, 2. This is f of x minus 4. I wanted to do the same thing for f of x plus 5, but I think that you'd be able to do it. Every single point from the parent function is moved to the move 5 to the left. 1, 2, 3, 4, 5. And then here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. That is okay. So it seems pretty simple so far. We just have to get used to recognizing the numbers. Once again, if the parent function was x squared, it would look like x minus 4 squared, or it could be x plus 5 squared. If the parent function was a square root, remember the x value is affected, or it is changed, it is transformed before the square was applied. Same thing here. The x is going to be, oh, you don't need a bracket. The x is going to be transformed by this -4, +4 rather, before the square root is applied. It would look something like this. So if you see a -4 or a +5 or whatever number underneath or inside the square root, it actually represents a horizontal shift. What would it look like for a reciprocal function? Same idea. Before we divide 1 by the x value is changed, is transformed. X plus 5. It looks like that. Any questions? Okay. Feel free to ask. We have just covered horizontal shift and vertical shift, which are 2 of the 4 letters in the exercise I gave you. That represents D and C. I'm going to summarize that in just a second. All right. And you might sort of follow this. It might seem familiar because you've done this in grade 10. The last one you have done in grade 10 is the vertical stretch value, or stretch factor, sorry. Let's clear this page. I'm going to go to the 3rd page, and I'm not going to do all of them because I feel like you can figure it out. I'll leave this exercise to you. I think you can do it, and then you can check the answer with the answer key that I put up online. I want to jump to 2 and then -1/2. So as I said before, I want to state that the 2, sorry, in this case, the A value equals 2. This means all Y values are multiplied by a factor of 2. See if I can, here. All Y values are multiplied by a factor of 2. Everything that this f of x gives me, whatever the answer f of x is, in other words, whatever the Y value is, it's going to be multiplied by a 2 afterwards. So visually speaking, let's see how that changes. Who was I at? Josh K. Are you ready for this?
Yep.
You could say no,
I'm
but
ready.
I'm still going to try it. All right. At this point, the point is -4, 4. Okay. That's my original parent function. But I have a vertical stretch factor of 2, aka the Y value is multiplied by 2. What is my new point?
-4, 8.
Yeah, so the -4 stays the same. Take a look at how high this is from the x-axis. It is now 8. 4 times 2 is 8. Would you continue on? The height of this is 3. So
No, -4, 6.
negative
Or sorry.
-2 and 6, yes. How about this one? The height here, the Y value is a -1.
-2, -1, -2.
Correct. Correct. And notice how, because you're multiplying by a negative, you're actually, oh, sorry, what am I doing? No, but the negative is after. I'm getting brain farts. Okay, the Y value here is a -2, and so?
-4.
Yes. And then here's a 1 and a Y value of 1.
2 and 2.
Correct. And now everyone take a look. Does this look like a function? Does this look like the parent function has been grabbed and pulled up and down? Yeah. This is 2 f of x. So in other words, just take the Y value and multiply it by 2. Right? Some examples, what this might look like if the parent function was an x squared would be 2x squared. If the parent function was a square root, the entire square root, the entire function is multiplied by 2. If it's a reciprocal function, the entire reciprocal function is multiplied by 2. And if you know your fractions, you know that you can write this as 2/x instead. So if you see a numerator with a number, you know that there's been a multiplication. So you can put a little star next to that. Any questions? No? All right, then let's very quickly do the exact same thing, but for a much harder or more difficult A value. So the A value in this case is -1/2. So that means all Y values are multiplied by -1/2. It's another way of saying you're dividing by 2. Please multiply by 0.5. Who's after Josh Hardy? Are you ready?
So would it be -4, -2?
Yeah, so it would be -4, negative. Yeah, it would be -4, -2. Well done. So take a look at what Josh Hart is doing. We've got the y value is a 4, but that 4 is multiplied by the a value. So the final value is a -2. The y value is -2. This point is -4, -2. Well done. Let's keep going. Josh, you want to keep going? The height is a 3 here.
Would it be -2, -1.5?
-1.5. Excellent. Oof. And then -1 times -1/2.
Would it be -1 and then +1/2?
+1/2. Good. So I know what you're doing. I'm going to fill in the rest. The -2 times 1/2 becomes -1. 1 times 1/2 is -1/2. 1 times -1/2. And then after you connect the dots, ask yourself, does this look like the function has been essentially smushed? Does it look like a vertical compression as well as a flip? And I'm going to say, yeah, it does. This is a -1/2 f of x. So again, as an example, if the parent function was an x squared, this would be just -1/2 multiplied by the entire function. If I was dealing with a square root, it would be -1/2 multiplied by the entire function. And if it was a reciprocal function, it would be -1/2 multiplied by 1/x. And again, reciprocal is a little tricky because it's fractions. If you multiply across, it turns into this. Please notice. The reciprocal function is very interesting because of fractions. What value again? What letter multiplied with x? Anyone? Do you remember?
A.
K, yeah. That is actually a k, but a k value is basically similar to a fraction a value for the reciprocal function. I just want to point that out because it seems coincidental, but it opens up for a lot of interesting interactions. All right. I believe that with all of this, now that we have covered vertical stretch, vertical shift, and horizontal shift, I believe that you should be able to put all of them in a combination. And so I'm going to give you a little bit of time to practice after we, no, let's do one example together and then we will do a summary on the very, very back page. I'm going to clear this. Would you please go to page number 5. It should have 6 different graphs on it. I'm going to clear this. Please go to page number 5. It should have 6 different graphs. And I would like you to try the second one on the left. I will give you 5 minutes. In case you forgot, when you're doing transformations, do transformations like you're reading a sentence. Go from the left and continue moving on from there. Some of you, because you will remember what you did in grade 10, you might have wanted to do the left, right, up, down at once, so you don't have to draw so many curves. That's up to you. I will leave that to you. That's what I'm going to do. Take 5 minutes and apply an a value of 2, a d value of +1, and a c value of -1, please. I will do this one in red, and then I will finish this off with blue in one go.
Mr. Kim,
Yeah,
should we do all the transformations separately or all in one like thing?
I am going to separate. I would recommend that you separate the vertical stretch and compression. And then the left, right, up, down, I think you can do it all at once. So don't worry about doing every single one. I am going to do the red and then the blue separately.
Okay.
Like I'm going to do the A first, and then I'm going to do D and C together. Just another minute or two.
When you do it, do you think you could like do like, I don't know, like a third demonstration? Like I'm just like a little confused.
A third demonstration? What do you
No,
mean?
no, I mean, sorry, like when you like show us this, do you think you could kind of like go a tiny bit in depth about it? Like how you got
Oh,
it?
sure, absolutely.
Mr. Kim, are you recording this?
I am.
Where do you post these recordings?
They will be on YouTube. When you go back to the class posting for this particular lesson,
Uh-huh.
I update that post by adding the Google link once it's fully uploaded. So if you go back to, let's say, stuff we've done in chapter 1, you will see a Google video attached to it now. So maybe by the end of today, take a look at my post for 2.3 to 2.5, and then a video will be there when it wasn't there before. Do you have a channel? I do, but it's not like, it's so embarrassing. Back when I thought I'd do some funny stuff for my students, I did make little like short vlogs about what you need to know for, you know, the different maths in preparation for university courses, trying to answer some of the more common questions that I got from my students. So I do have a whole bunch of that, but I'm a little embarrassed, so I'm not going to tell you. Just use the link, and if you're really curious, I'm pretty sure you'll be able to find me using the video links on our Google Classroom. All right. No more questions about that. You're going to embarrass me. All right, let's go a little bit more in depth. As I was saying, I'm going to do transformations from left to right, so I'm going to tackle the A value first. So if this black function is my parent function, I want to turn that parent function into this. Just to go one step slower, please remember that this point, again, it's in black, is -4, 4. In other words, when x equals -4, my y value equals a 4. An a value of half is multiplying with whatever that y value is. If you remember function notation, what is f of x? F of x is the same as the y value when you plug in an x, right? So essentially what you're doing with the half there, 1/2, is you take the y value of every point and you are going to multiply it by half. So leave the -4. What is 4 times half? 2. So my new point is going to be -4, 2. Is that good? Is that a good pace? I hope so. I'm getting silence. Let's keep going. In the original parent function, once again, this point is -2, 3. I'm not looking at the x value here. The vertical stretch is called vertical is because it affects the y values. It affects the vertical values. So what is 3 times the vertical stretch? It is 3/2 or 1.5. The new transform point is now 1.5. And I'm going to continue this pattern. The value here is -1, -1. The y value is a -1. If I apply the stretch factor, this is -1/2 or 0.5. My new point is negative, has a y value of negative 0.5. And essentially what I'm doing is just multiplying every single point, and it will turn into this. And you know you're doing it right because take a look at the red versus the black. The red looks like I took some kind of anvil on the top and bottom and I crunched them together. It's smushed towards the x-axis. It is a vertical compression. Does that make sense? How's that? Okay, I hope that was okay. And any questions about that? Or should I explain a little bit deeper? Okay, I'm gonna assume it's okay. This radio silence is sort of making me worried. Anyways, now that we're here, I'm gonna take my blue and I'm gonna apply my transformation 1 unit to the right and 1 unit down in one go. Bam, 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 and bam, bam. There it is. That's it. This is half x minus 1 minus 1.
Why did you like the the right and down transformation makes sense, but why did you put it as D and C?
So instead of doing, x minus h squared plus k or anything like that, we
Yeah.
are now moving on. We're not dealing with vertex anymore because the curves that we're graphing aren't going to be just parabolas. So we need to find new letters that can sort of be used for all types of functions.
Uh-huh.
So in the grade 11 level, we are going to represent all the different possible transformations with these new letters. And so the A is the same, vertical stretch, but the H that you've been dealing with is now going to be called the letter D. It is going to represent the horizontal shift. And the K that you had before will now be written instead as C. The change happens from grade 10 to grade 11 because we're going to be dealing with so many different curves afterwards.
Okay.
Is that okay?
Yeah, thank you.
What does the
And of
F
course,
mean?
yep. The F is original function, whatever the function is.
Oh, okay. Thank you.
It's the function notation. So in this case, f of x translates to x squared. So this part right here and this part right there, that is the f of x in this particular case. I know
Like
it's a
in the
little bit
next one-
funky, but you'll get to use. Yep, go ahead.
Sorry. I was just in the next one. How can the f be
Huh?
negative?
And a negative f is simply means that a -1 is multiplying to the original function. In other words, I'm dealing with a -1 as my a value. A -1 in front of the function means that I am going to multiply the y values with a -1. Just as how I was multiplying a half, all the y values are going to be multiplied by a -1 instead. Want to see it in action? We can do this one. Well, you know, the only problem is I haven't taught you K yet. So it's going to be a little weird. Can you hold the thought a little bit? Let me give you a summary, and then I'll finally introduce you to the last one, which gives you all the tools you need to sort of swim around and explore the space, okay? So just bear with me. Clearing this, I'm going to go straight to the very last page, and let's fill in the charts together. Let's summarize everything that we learned so far. Okay, so the top portion, the top two boxes represent all the things that happen to me vertically. Another way of saying that is it affects the Y values only. And in the same way, in the very bottom, horizontal transformations, the two letters are going to affect the X values, okay? So what am I dealing with here? The A value and the C value represent vertical transformations. Specifically, what do they represent? This A value is called the vertical stretch factor. And of course, it can also involve reflection on the x-axis. If that A value is a negative, you know that's going to result in a reflection. So bear with me here. If the absolute value of the A value is greater than 1, in other words, an absolute value of 2 is greater than 1. An absolute value of -2 is also greater than 1. In other words, if the absolute value is larger than it used to, larger than 1, larger than it was before, then f of x is going to be stretched out vertically. If A value, the absolute value of A is going to be a decimal, a smaller number than 1, but bigger than 0. So if it's going to be a decimal, then f of x is what we call compressed. Here's an example of how we are going to talk about it. If x to the power of 2 has been transformed into 1 over 2, x to the, 1 over 2, x to the power of 2. Okay, we would say that this has been compressed. So we say this is a vertical compression. That's what's happening to the graph visually by a factor of, what am I multiplying to the Y values? By a factor of half. We're multiplying half, so we say a factor of half. Some of you might not like the wording, but this might make more sense. It means that if you're given an XY point, having an A value of half is like doing this. You are taking the X and you are taking the Y and you are multiplying with whatever A value is, just like how we were doing in the graph. I'll pause right there. What do you think? This is everything that we've been doing in our diagrams, in our examples. I'll give you a chance to think about it. Any questions for the vertical stretch factor? No? You may want to write a little note. The way you talk about it verbally in words is you state what is happening visually. Okay. And then the number that you write here is what is y multiplied by. Okay. The next vertical transformation is the vertical shift or translation. So if this is C, C appears positive, then we are shifting up because the C is in fact positive. If C appears positive, it's because C is positive. If C appears negative, then shift down. C is in fact negative, so we have to go down. Once again, for those who are more mathematically inclined to just look at an equation or you like formulas, it basically means that you take your XY point and then it becomes, the Y value becomes simply added by the C value. There it is. What do you think? Okay. All that's left in terms of grade 10's material is to do the letter D, which is the bottom right box. It is the horizontal shift. And if you remember, there's a slight reversal in the sign where if it looks like it's a negative, then the D value is actually a positive and vice versa. So I'd like to move on, but I'm afraid that, you know what? Please visit the recording or take a look at my answer key if there are any parts that you are missing, because I'm basically copying this word for word from my answer key that I wrote like just a couple of days ago. All right, I'm going to clear this for now. So don't fret, it's still somewhere online, okay? It's in our computer, it's in our classroom. I'm going to move on to the D portion. And again, we're moving on to K and D, but you don't know what K is yet. The D portion is what we call the horizontal shift. And to mimic or to go parallel with the vertical shift, if the D appears positive, then we're actually shifting left because the value of D is a negative number. If D appears negative in the equation, then you're actually shifting right because the D is positive in value. Once again, for those who are more inclined to use formulas, D is simply added to the X value, but it leaves the Y value completely alone. We're only looking at how it shifts it left and right. We're only looking at how it affects the X value. Which brings us to the final one. Okay, this I need everyone's attention. So I'm going to wait until people give me a thumbs up showing me that they're ready for the next piece. Just need everyone to pay attention. This is the new part. This is what makes it grade 11. So I'll wait until I see more responses. Okay, that's most people. Just a couple more. Okay. There's a couple people that might be actually missing, so nice. Okay, that's like 95%. So I'm gonna move on. Okay, this is what makes it grade 9. This is called the horizontal compression factor. See how it's different from stretch factor? And of course, plus a reflection horizontally on the y-axis. If there is a negative in front of the x value, then it's reflecting on the y-axis. Okay. All right. Are you ready? Just as how if the D appears positive, it's actually negative. The same idea applies to a multiplication. If the K appears to multiply to a big number, we're actually multiplying it by its reciprocal. I lost a lot of you just now. I know I did. So let me write it down in text and then I'll show you what it looks like in action. If the absolute value of the K value is bigger than 1, then it's compressed. It actually gets smushed. Okay, so if the K value is 2, I'm actually smushing it. In other words, I'm dividing it. I'm making it smaller by a factor of half. So if the K value is 2, I'm actually dividing by 2. Okay. In the same way, if the K value is a decimal, in other words, the value itself is smaller than 1, the absolute value itself is smaller than 1, then the f of x is stretched. So think about it this way. If the K value is 0.5, is a decimal, it's half, then you're actually multiplying by 2. It makes more sense to do it mathematically. So take a look. xy, if it is transformed, you are multiplying the x by a 1 over k times x. Now, how do I write this? I'm gonna, you know what? I'm gonna do it in writing. It leaves the y value all alone, and the x value becomes multiplied by 1 over k. Or another way you can do it is just x divided by k. Some of you might still be lost. They're like, I don't understand the relationship. That's okay. Let me give you an example. E.g., let's pretend I have x squared and it's being transformed into 1 over 2 x to the power of 2, right? K value is equal to 1 over, no, let's keep it simple for now, 2. The K value is 2, which means we say there is a horizontal compression by a factor of half. Everything is going to be multiplied by 1 over k, 1 over 2. Here's another example. If x to the power of 2 was transformed and now we have 1 over 2 times x to the power of 2, the k value is 1 over 2 and we say this is a horizontal stretch by a factor of, what am I multiplying by? 1 over k, so 1 over 2, which is 2. Oops. Again, I know I lost some people. Some people might understand what I'm doing because I described it in words. Some of you might still be like, what the heck are you talking about? Maybe you'll get it once I show you some examples in our handout. Let me write this down. Okay, are you ready? What's a decent one we can start with? Let us go to, I think it's page 4. Let's go to page 4. It will give our first example, first sort of simple form of horizontal compression. All right, here it is. F of 2x. You ready? So let me write a little blurb right here. Okay, so the k value of 2 means all x values are transformed by a factor of 1 over k, so 1 over 2. All x values. So I'm going to walk some people through. Maddie, are you with me?
Yeah.
Okay, what is the x value for this point?
Would it be 2?
Oh, yeah, okay, so I was going to say -4. -4 is the x value of the original. It is going to be multiplied by a half. So what would it be, as you said?
-2.
-2 good. Can you continue? What is the x value of the original function?
-2.
And if I multiply that by a half, it becomes?
Negative.
Yeah, let's do it.
-1.
Yeah, -2 times half is -1. The x value for this is -1, so -1 times half is -half. It's -0.5. So now I'm dealing with here. Well, how about this one? What is the x value of that? Let's see. Marin, are you there?
Yeah.
What is the x value of this original parent function? Right, point right here.
I honestly don't know.
Oh, come on. I'm looking at a point. It's an xy. I'm not asking you to do math. I'm asking you to tell me what the point is. What is the x value of this point? Really? Can you give me the xy? What is the coordinate of this point right here? Not quite sure?
3,
Okay, maybe we'll oh,
-2.
yep. Yeah, 3, -2. Excellent. So we take the x value only. I'm not even going to deal with the y value. Take the 3. I'm going to ask you to multiply it by the same k factor. It becomes 3 over 2 or 1.5. That's all it was. I didn't mean to put you on the spot like that. I just wanted to ask what the x value for that was. Okay? In the same way, if you look at the x value of this point, 1, 2, 3, 4, 5, the x value of that point is a 5. And so take the 5, we're multiplying it by 2. That's 2.5. It's right here. And lastly, the x value of this point is a 6. We multiply that by a factor of 3, and it gets smushed, and it becomes a 3. If you connect the dots, do you see how the entire function has been squeezed horizontally and it's been compressed? This is what a k value represents. Oops. What do you think? Some examples, again, if this was an x squared, the example of this would be the x becomes, the x is multiplied by 2 before it is squared. If it is a square root function, the x is multiplied by 2 before the square root. And if this is a reciprocal, the x is multiplied by 2 before it is divided from 1. That's what a k value would look like. Okay. At this point in time, someone might ask, why does a value of 2 mean the x value is actually halved? This is the best example I can give for those who are able to, like, you know, sort of wrap their head around it. If f of what is the value of the original function? What is the y value when x equals 6? 1, 2, 3, 4, 5, 6. When x equals 6, my y value is 1. Okay, but now the function has become 2x. What does x have to be for the entire 2x to equal the same as 6? If you want 2x to equal a 6, x has to be a 3. Long story short, when x equals a 3, it's as if x is a 6 in the original function, y becomes 1. That is why when x is a 3, y becomes a 1. So this is the idea behind the transformation and why it looks like it's doing the exact opposite. Okay. You might have questions. Hold those questions and see if they can be answered by our second example. If I have, clearing here, f of 1 over 2. So again, this time the k value is 1 over 2. So if that is the case, I am multiplying, remember, x to y becomes 1 over kx comma y. What is 1 over k? 1 over k is 1 over 2, which is the same as 1 divided by 1 over 2, which is the same as multiplying the reciprocal, which is the same as 2. Multiplying by 1 over 2 is the same as multiplying by 2. This is why when you see this as a fraction, you're essentially multiplying what we would say is the reciprocal. Okay. Once again, in text, I will write k value of 1 over 2 means all x values are transformed by factor of just 2. Everything is being multiplied by 2. All x values are multiplied by a factor of 2. I'll say it one more time. All x values are going to multiply by 2. Monica, are you with us?
Yeah.
Here is an x value of 4. Oh, sorry, negative 4. What would the new x value be for the transformed graph?
-8.
Negative 8. So that point right here became negative 8. How about the negative 2?
-4.
Negative 4. Could you continue? Negative 1 becomes?
-2.
Okay, and 3 becomes?
6.
Mm-hmm.
And then
5
10.
becomes?
10.
Huh?
And there's no room.
And then, yeah, that's a 6. The last one's a 6, so it was 12. This is my horizontally stretched function. So example, if I had x squared, this would become, it would look like this. A 1/2 is multiplying to x before the square, and that results in a horizontal stretch. If it was square root of x, that would be 1/2x inside the square root. And if it was a reciprocal, it would be 1/2 times x. 1/2 is multiplied by just the x. But if you recall my little manipulation of numbers above right here, 1/1/2 is just like me saying 2. Okay. Oof. So at this point, we have covered at this point, we have covered 4 different transformations. When we get together tomorrow at 2 p.m., we are going to look at how we can break down all 4 transformations from a given equation, like using parent functions, and then doing what we did here, multiplying it by a 2, dividing it by a 2, multiplying by 1/2, blah, 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 blah. I am hoping that I will be able to show you, if you know how to work all 4 numbers, you can graph anything in grade 11 and beyond. And the whole goal is that you look at 4 numbers and you're able to be like, bam, sketch it instantly, that it doesn't take you that long. Because in grade 12, what's it called? It's called advanced functions. If you're doing grade 12 math, you need to be able to sketch functions like crazy. Half of advanced function is just purely curve sketching. There's like a unit called curve sketching. And then if you are one of the people who are doing advanced functions and calculus, guess what? All of calculus is about checking to see what the curve looks like. Like it's all about curve sketching. So we need to be able to put this under our belt and say, I can sketch it at any point in time. I want to keep you longer, but that's not fair for you. So when we're trying to do use AK, CD, AK, would you do? Yeah, so it's sort of like you're doing it in left to right, like you're reading a book. Do A and K first, and then D and C together. Okay, let me give you a quick thing. What you can do for practice is basically everything else that we have yet to do together on this package. That's essentially your homework. You don't even have to look at the textbook, right? Like this one, for example, this one, for example, yes, it's a -1/3, but remember, if the K value is -1/3, what is 1/K? It's 1/1/3, which means it's basically multiplying all the X values by a -3. See if you can do that, okay? And one last thing is something that I was able to cover with the other class because I had time with them. I'm going to give this to you. Please note that the K value has to be factored out. And this is something that Mr. Kim will probably put inside a test to trick you. The K value has to be always separated from the other parts of the function. So if it's not, if it's just 2x plus 2, you got to factor out whatever it is with the x. Same with this. F of x is actually, it should be written like this. You should be able to factor out a -1. If you have no idea what I just did, don't worry about it. Maybe we can start next class with this, and then I promise we'll have ample time. So we will revisit this together. Do as much as you can and come tomorrow at 2 p.m. with questions. Okay? I'm expecting someone to be like, hey, Mr. Kim, can we do, the third one on the 5th page or something like that? We'll be like, okay, let's start it. And that's how we will begin our class tomorrow. Questions? Okay, I'm going to assume that's okay. If you do want me to do something, if you want me to show you in detail through a video, or if there's a textbook question you ran into, you're like, I really want to know right now or as soon as possible, send me an email, send me a message on our Google Classroom, do whatever you need to reach out, and I will make like a quick 3-minute video. Should be more than enough for me to explain the question there. All right, you are officially dismissed. Before I go, if I didn't catch your if I didn't get your attendance, then please let me know. Alex, I got you. I am going to go in right now to make sure that you're not absent. And Felix, are you here?
I'm here.
Perfect. Okay, let me take you off the absent thing. You're here. Okay, that's good. You're officially dismissed. If you want to stop here or stop by or just hang out for a little bit just to clarify something,